Okay, well, we were going to talk about this on Monday, but Monday is now going to be Wednesday, and we're not going to be allowed to meet in person. So let's go ahead and take a look at now Chapter 7, or I should say Lab 7, for you guys on geologic time. Now, you guys already have your lab books, so everything is pretty much self-contained for this lab in the lab book, including the discussion, which basically goes right over, again, what we discussed in class. About the immensity of geologic time, how it is a concept that for most students is rather difficult to pick up because you're dealing with concepts of time that go well beyond what you are used to dealing with. Okay, the average human life is almost 100 years, and for many people, especially young people, it's incredibly difficult to fathom that long of a time. Sometimes just the 2 or 3 hours I'm talking in class seem to take forever. And if you are young enough or old enough, depending on the case, to remember clocks in the classroom, the end of the day, that last 5 minutes just seem to take forever to get through. So, but there are 6 key principles to keep in mind that you're going to need in this lab. That's going to be the law of superposition, the idea that in an undisturbed stack of sedimentary and or extrusive volcanics, the oldest material is going to be on the bottom, the youngest material is going to be on the top. The principle of original horizontality, the idea that sedimentary rocks are laid down horizontally in relationship to the local surface or the local area. The principle of floral and faunal succession, on how life changes over time and how we can use that to then correlate for different rocks. We're not going to do any correlation in this lab, so you don't have to worry about that. The principle of cross-cutting relationships, on how something has to exist first before it can be cut. So anything that cuts through something has to be younger than what it's cutting through. The law of inclusions, or included fragments, which just basically is talking about how if you have a piece of something that is included in something else, the piece that is included has to be older than what it is included within. So it's like you can't put the chocolate chips into the chocolate chip cookie after you made the cookie. You have to put the chocolate chips in before you make the cookie. And then finally, the principle of the unconformities, the angular unconformity, the disconformity, and the nonconformity. And just remember, basically, while all 3 have different physical expression, they all mean the same thing. They're all talking about time that is missing within the sequence. When you go through this lab, one of the things that you're going to be asked to work on is a block diagram much like this. Okay, not exactly this one, but much like this one. And what you're going to have are the different units are going to be labeled with letters. And of course, since I'm doing this video on my iPad, looks like the letters are going to end up being reversed for you. So, but the idea is trying to figure out what came when. So using those relationships, those 6 principles or laws, as well as the ideas that we used from relative age dating. Remember, we're just going to try to put things into their proper order. You're going to try to figure out what the order of all of these letters are. So if we look at this one, and I'll have to try to figure out how to do this better for you guys, but this is what I can do right now. What in here is going to be the oldest material? Well, looking at it, most likely answer is going to be E. Is going to be the oldest material. Okay? And that looks like it's, in the way this is drawn out, that's supposed to be an igneous body. Right next to it, you see these black wavy lines. That's supposed to be a metamorphic body. So probably this body is probably a little younger. Now, H is actually referring to this surface right here, which is an unconformity. So H, it's probably going to go E, H, D, then I, It's going to come over here to L, A, M, G, K, J, and B. And a lot of this is just, again, using the idea. So the H and D reference is very simple because H is an unconformity. It's a nonconformity between older metamorphic rocks and younger sedimentary rocks. And so D, the units of D have to be younger than H. I is an angular unconformity between the units that make up L, parts of L, and I. So since the units below I are tilted and the units above I are flat or horizontal, they have to be younger above that level and older below. M, we're just using original horizontality. When it comes to G, we're actually using cross-cutting relationships. So G is a magma body that came up, produced a pipe, a sill, a volcanic neck, and then produced a volcano. Well, you can't create the volcano until everything else forms upwards. So the volcano formed, the volcano then had a lava flow, and the river cut the lava flow. So that's how we can sequence this. When you guys are doing this, the diagram that's in your lab book, a little more complex. Yes, I know it's a little more complex. But all you're going to be doing is putting these items into their proper order. Now, keep in mind that the letters on here are going to represent the rock units. The numbers are going to represent unconformity surfaces. So you can use those to help you get it, but all you're having to put into order are the letters. And I will go ahead and give you this hint right now on what are the oldest and the youngest to get you started. The oldest is D. The youngest will be F. Then it's up to you guys to put the rest into their proper order. Now, keep in mind, there is potentially more than one right answer, simply because there are a couple of things in here that don't give you enough information to understand fully what the sequence is. This is normal. This is normal and natural in the geologic world. There are times where we get to where you can make more than one interpretation of what a block diagram or what a sequence is doing in the field. And so I want you guys to experience that, but don't worry about it. I've accounted for that in the way this is graded. So all you have to do is put it into the order that you think is best. There's one or two things that, depending on how you interpret them, can go into slightly different places. But as long as they're in generally the right position, you should be fine. Okay? Most of the rest of the next three questions in the lab are going to be about the block diagram and the sequence you came up with. So you really are going to have to work that block diagram out before you can answer questions 2, 3, and 4. Beyond that, we get into absolute dating. Now remember, absolute dating or radiometric dating is based on how much time has passed by, using the fact that radioactive elements decay over time, and they decay at a very specific rate. That rate we call a half-life. So over the course of one half-life, half the material goes away. Over the course of 2 half-lives, 3/4 of the material has gone. So remember, every half-life is half of the material remaining decays. Now, as I mentioned in class, there's this nice chart showing that decay process. This is accurately graphed, so you could use this potentially in some of the questions. I also give you in the questions the actual mathematical formula for this line solved for either half-lives, number of half-lives, or percent of parent material. That will allow you to do it through calculator if necessary, or if you want to. However, you can read this chart and be accurate enough to get the right answers for those lab questions. And then also, you're going to be asked questions about trying to figure out how old something is based on number of half-lives. There are the half-life in years here for several different elements that you're going to be asked to consider, and that's a simple math question there. And then lastly, the geologic timescale, just to introduce it here, because you're going to be needing it in the next lab. In the next lab, I'm going to have to figure out, because the next lab, I want you guys working on maps, actual maps, to get a feel for how to actually read the maps and how to use the maps. That's a little more difficult now that the maps are locked up and access to the building is kind of non-existent. So I'm going to have to try to figure this out and figure out a workaround for you guys. But we'll get it done. This is also going to mean that, as of right now, the lab final is going to be online. The class final is going to be online. The class final, not a problem. I did that last year. I can do that, no problem. The lab final is a little more problematic for me at the moment, simply because the lab final is supposed to test your ability to make observations, in particular on samples. Kind of hard to do that if you guys can't handle the samples. So we're going to have to figure out what the workaround on that's going to be. It may just end up being photos. And no, it will not be stock photos, so you can look them up. There will be photos I take. It means I get to use my my white box. Cool. So we'll have to figure that out, although I don't have access to the samples either. I'll have to pull stuff out of my yard, or my collection here. This is going to be interesting. So we'll get this figured out. We'll get this done, but it's something that we're going to have to work on. Bear with me. Changes all around, thanks COVID-19. So anyway, geologic timescale. We're going to be using this more in Lab 8, a little bit more in Lab 8. Maybe even touch on it a bit in 9. But it basically is the same thing that was in the classroom on the wall, but instead of being 2 charts, it's 1 chart. Not too much that we need to know about this. It's really in the geologic maps, so we're going to pull this out. So with that, I'm going to go ahead and end this now. It's going to be a relatively short video. Hopefully, I'm going to try to figure out a way that during class times, I will be available online some way, shape, or form. There's something called Google Classroom or Google, some sort of Google thing. I'm going to try to see if I can figure out. As you can imagine, I'm buried in emails from all 4 of my jobs about the COVID-19. I literally am getting 100 emails from each one a day, it seems, at this point. And it's just it's an avalanche of information, and trying to keep up and keep informed is a little more challenging than I would really like to be at this point. But hopefully I'll get caught up today and figure things out. Again, we're not supposed to meet until Wednesday, but we'll see. As far as your labs that are due and the labs that, or the midterm that I have to turn back to you, basically, as I put out in the email, probably the best bet is for you guys to come on an individual basis to my office located at 2150 North Congress Drive, room 116, but it's labeled as 115. Since I work at the county, it's kind of a good central location. Don't do it all at once, obviously. Follow good practices there to keep yourselves and, more importantly, the older members of your family safe. And drop them off or pick up things, and we'll go from there. And we'll get through this. It's going to be a little bit of a challenge, but hey, that's life. So with that, you guys take care. If you have any questions, feel free to either email me. I'm going to try to see if I can get the forum section in the class working so you guys can ask questions there. And we'll see what else we can come up with. Have a good one.